Welcome to this optional video on quadratic equations. First, we will define a quadratic equation and then we'll describe how to solve them. So by definition, a quadratic equation is a single variable polynomial equation of degree 2. In other words, every quadratic equation has the following form: a times x squared plus b times x plus c equals 0. Where here you have a polynomial function of degree 2 and you make that equal to 0. And to solve this quadratic equation means to find the value of x, the variable x, that satisfies this equation, given that the coefficients a, b, and c are constant real numbers. So the first concept we're going to need to solve quadratic equation is called the discriminant. It is denoted by the uppercase Greek letter delta, and it's defined by the formula b times b minus 4 times a times c, or b squared minus 4ac. Now we will distinguish three cases based on the value of the discriminant, and I'm going to summarize these three cases in a theorem. If the discriminant delta is positive, then we can take its square root. And in this case, the quadratic equation has exactly two distinct real solutions or roots. And these two real numbers are defined by these formulas. The first one, R1, is equal to minus b plus the square root of delta divided by 2a. And the second root or solution of the quadratic equation is given by R2, with almost the same formula except with a negative sign here. Now, this is the case that we are interested in solving logs, because this is the only case where the quadratic equation has two distinct roots. But for the sake of completeness, let me briefly describe the other two cases. The second case is when the discriminant is 0. Well, we could still take the square root of delta. Of course, the answer will be 0, and therefore, using the same two formulas, we observe that we'll get a single real root or solution, namely r equals minus b over 2a, because square root of delta is 0, so whether you add it or you subtract it, you'll get the same answer for the root, namely this one. And then the third case is when the discriminant is negative. Then in this case, you can't take the square root of delta unless you consider complex numbers. And indeed, this solution has two distinct complex solutions, but these are complex numbers we're not going to deal with in this class. So here is the complete theorem. And again, for our purposes, this is the case that we are interested in, because we always assume that the quadratic equation we obtain in the process of solving a log will always have two distinct solutions. So let's wrap up this review with a couple examples. First, we'll consider this quadratic equation x squared minus 3x plus 2 equals 0. So the first step is to compute the discriminant delta, where b is minus 3, a is 1, and c is 2. So delta is b squared, or 9, minus 4 times 1 times 2 minus 8, that's 1. So the square root of 1, of course, is 1. And when you do minus b plus the square root of delta divided by 2, you get 3 plus 1 divided by 2 is equal to 2. Now to get the other root, you simply change the plus sign to a minus sign here, so you get 3 minus 1 over 2 equals 1. It's always a good idea to check your work, so make sure that when you make x equal to 2 in this polynomial, you get 0, and similarly for 1, which is the other root you found. So here for 2 we have 4 minus 3 times 2 is 6, that's minus 2 plus 2 equals 0. So this root works, and for x equals 1, we got 1 minus 3 times 1 is minus 2 plus 2 equals 0. So clearly these are the two distinct real roots of this quadratic equation. Now let's look at a second example. This time the equation is x squared minus x minus 1. A is 1, b is minus 1, c is minus 1. So delta is b squared, or minus 1 squared, or 1, minus 4 times 1 times minus 1, meaning plus 4. 1 plus 4 is 5. So here is the discriminant here. And in this case, the first root is 1 plus square root of 5 divided by 2. In this case, it's not an integer, it's really a real number. And the second root has the same expression except with a minus sign here. So I will conclude this video by asking you to check that when you plug in R1 for x, you get 0. And similarly, when you plug in R2 for x on this left-hand side, you also get 0.